we can use 15 seconds of speech, and through that we can get a comprehensive look at somebody's state of body and mind. You can hear diabetes too through voice, we found.
That sounds crazy. How does that work? And we'd love to start with some intros. Stefano, Amelia, thanks for connecting. Good to see y'all. Excited for the team to be on the pod. Maybe we start with some intros.
Sure. Yeah. Thank you so much for having us. It's great to be here. Very excited. I'm Amelia. I'm the CEO and co-founder of Thymia, joined by Stefano,
CTO and co-founder. Thank you so much for having us.
Yeah.
Of course.
Happy to go into our backgrounds if you'd like now a bit more, or we can go into that separately.
That sounds great. I think background is great. You guys have a very interesting, unique origin story as a team, as individuals as well. I think people watching this will be really interested in kind of what led to the creation of Thymia and what were you doing prior to this that ultimately caused the team to unite and kind of meet here.
Yeah, sure, absolutely. So as I mentioned, I'm CEO and co-founder. Stefano and I founded Thymia almost 6 years ago now, but prior to that we had extremely different backgrounds actually to each other. I was a researcher for about 12 years. I spent most of my time at UCL. I did my PhD there, a few postdocs focusing on neuroscience and linguistics. So my particular specialty is looking at language and using language essentially as a biomarker for cognitive function. So I worked with Alzheimer's, Parkinson's patients, aphasia post-stroke, depression, schizophrenia, but for all of them doing the same thing, essentially looking at their language use as a lens into how they are actually progressing with their therapy, their treatment, and so on. I actually loved my research a lot, as many academics do. I had every intention on remaining an academic, and everything changed for me quite literally overnight, or over a period of one afternoon, I would say, when while I was doing my research, actually my best friend developed depression, and I saw her firsthand go through the process of trying to get help in the NHS in the UK. She unfortunately didn't really get the help she needed there. She went privately, she saw a psychiatrist, but even he didn't realize how bad her condition was. And just 2 days later, she ended up trying to take her own life. And when that happened, we were meant to be meeting that day. She didn't show up, so I was actually the one who found her at her house, which, as you can imagine, is very much a life-changing experience and moment. Thankfully, it's positive. She's doing a lot better now. She's on a very good recovery pathway, but it should never have happened in the first place. And for me, that was the completely, I would say, changing moment in my life and in my career, in that I ended up leaving academia kind of within a week. I quit my postdoc and realized, well, research is great, but if you don't actually bring that research into the hands of clinicians and people who need it, then it's ultimately kind of worthless. You can write 1 million papers, it doesn't make a difference. So yeah, I wanted to basically help other people like my friend, bringing objective biomarkers into the hands of clinicians, and needed somebody to help me build that, and joined an accelerator program in the UK, Entrepreneur First, and that's where I met Stefano. Very different background, but super complementary skill set and personalities, it turns out. Perfect for building this.
Indeed, yeah.
Hand over.
Thank you. Yeah, so indeed, very, very different background. Very technical on my side as well, but then a different non-linear path leading to Thymia eventually. I did my PhD in theoretical physics. I was studying the Higgs boson. It was a little before the discovery of the particle. I did not contribute much to that. It was a good theoretical exercise, not very helpful. But a good timing. So it was just before, so quite exciting time. After my PhD in physics, I did kind of an initial pivot in my career, and I started working as a quant in finance. which is not so uncommon for
I know a lot of physics people
yeah,
who are quant.
Physics or maths is quite common. Like is a way that you know you're not gonna waste the skills, the mindset you developed, and so it may feel natural. It did feel natural to me at the time, and then after working for some time in that industry, I spent almost 8 years, something like that, yes, in places like Citibank, JP Morgan, on the trading floor. Quite exciting projects, very noisy environment, and all of that. But after a while, I realized I was actually extremely bored. I could not care less about what I was doing. That's the thing. The how, extremely exciting. I learned so much. The environment is super rich in terms of brain density. There's a lot of smart people and you learn a lot. But I could not find the reason why I was doing what I was doing. So at some point I decided to leave and trying to look and do something better. And I didn't quite know what. I just wanted to do something better with my energy, essentially. So I was lucky enough to meet Amelia pitching Thymia at Entrepreneur First, and it clicked immediately. It just made so much sense. She was pitching a very powerful pitch already, like it's 6 years ago, and it was a concept at the time. Like now the thing is there, but it was so powerful already. Like the idea really to use cutting edge science and embed it into engineerable products to actually make a difference. It was powerful and was real. So I said, okay, well, let's give it a go. It's not my field, but we'll learn. And so we started. And that was almost 6 years ago.
Yeah. Yeah, so I guess now we're at the point where, as Stefano said, it's kind of a reality. We've gone through various iterations of what Thymia is, like the product, the concept, everything, but it's very similar to what the original idea was, which is let's try and use speech as a marker for health. So now we've got to the point where basically we can use 15 seconds of speech. It can be any speech gathered by any device, and through that we can get a comprehensive look at somebody's state of body and mind. So starting with mental health, which is kind of the original point, we can identify major depressive disorder, generalized anxiety disorder, but also all of their core DSM-5 symptoms. So these are the psychiatric symptoms somebody looks for, like fatigue issues, sleep difficulties, mood swings, attention, concentration, excessive worrying, and so on. We can isolate and quantify all of those independently of each other, which is a really big feat in itself. We have a more earlier stage / wellness version of those models as well, where we're looking at early warning signs like fatigue, changes, burnout, stress, distress, all of these kind of not necessarily a medical device, but also very powerful and usable. And we've also recently expanded into physical health. In gathering the data set we gathered, like that was kind of one of the key things we've done is gathered our own data set from scratch for the past 6 years. It's the largest of its kind. It's so broad and richly labeled that we actually started to realize voice is not just tied to mental health, it's tied to the nervous system more broadly. You can think of voice containing these signatures for your nervous system health, like which we are kind of calling now neural morphemes, the smallest kind of conveyors of nervous system health. Let's say you can hear those in the voice.
What are some examples? What are some examples of those? Are they audible? Like, would a human be trained to determine these, or is it actually a signal processing challenge where it's maybe in a frequency domain is where you're trying to understand the kind of spectrogram? So curious on, is it perceptible? Like, would I be, could I be trained on the feature side and kind of get close, or is it actually much more kind of nuanced and subtle?
I would say it's a combination. Probably it's a combination. So if you think about speech, you can kind of think about it it's multimodal and it has different dimensions. One dimension is the spectrogram, as you said, like the acoustics of your voice. How do you sound? Loudness, like decibels, frequency, intonation changes. Like how exactly are you controlling your vocal cords? So are the muscles relaxed or not around your throat? do you have good lung capacity? So are you actually breathing deeply enough or not? Is that damaged? So some of those things you can kind of hear. Like, for instance, with depression, you may know a friend, for instance, of yours, how they speak. If they are going through a low mood period, you may be able to hear that, like flat voice and so on. So some aspects there you can probably hear. Other aspects there is very difficult to pinpoint for the human ear. There are thousands of features that you can identify and tie to depression, but also respiratory health and even diabetes. So that's a really interesting one. You can hear diabetes through voice, we found. And then
that sounds crazy. How does that work? How's that possible?
Yeah. So there, it's kind of, for diabetes in particular, it's looking at nervous system damage, which is associated with kind of chronic diabetes type 2, neuropathy basically, which is expressed in nerve damage around the vocal cords, within the capillaries in the lungs, your breathing capacity. All those things kind of create signatures in the voice, dehydration, dry mouth. Putting them all together, you have like kind of this signature for diabetes. That's very much acoustic, but there's also another layer of speech, which is the content layer. So what exactly is somebody saying? There, it's unlikely that you'll hear really stuff so much about diabetes, but you can hear stuff for depression, anxiety. So like the words, content, like meaning, structural complexity, and then also timing, like is somebody speaking slowly, fast, and so on. So some of those aspects are audible to the human ear, and many doctors are they train themselves to hear these things, but then there's a lot that you can't really hear, and you rely on AI to identify.
I think there's something interesting there as well that is more in the region of things we're working on, not in the region of things that are there already, which is in a sense going all the way backwards to something that is very explainable, and so maybe you could be trained on. If you look at how the models are actually working, what we are indeed doing is building self-supervised embeddings that represent speech in a compact way and do capture this paralinguistic information alongside with the linguistic information, and don't wash out the health data, which is what would normally happen with, say, off-the-shelf embeddings. Once you work in that space, sure thing, even if you did a little bit of explainability, you don't learn much if the feature number 1021 is an indicator of depression. You don't know what to do with it.
What does it mean? What does it mean?
Sorry, say it again.
Yeah, it's like, what does it mean? How
exactly.
like practically, like, what does it mean? I see a pattern here, but now I'm trying to get a better sense of if this is high, this is low, what does it actually mean?
Correct.
In a more visualizable sense.
So they were starting working a bit with like make interpretability style of approaches, where we are trying to reverse engineer and say, okay, we see these features are important for this condition or for this type of symptom. Can I project back into a space that actually makes sense to a human? And for example, if you stay in the acoustic space, can I go backwards and project it to a certain type of frequency that have been studied in scientific literature before, and kind of reworking your way towards something that someone could actually like name with name and surname and maybe hear if trained, which is weird because it's where this stuff started. Like if you look old papers, it was all about manually engineered features. It just did make sense in the context, but the power they have is limited, and you see it. The more you get data, the better you are off using bigger embeddings essentially, but you lose that explainability bit. And now we're trying to bridge the gap again backwards. It's gonna be really cool to see. Mm-hmm. But
this is super interesting for me because back when I was at the University of Waterloo as a student, I was doing research around medical image search and trying to gather clinically relevant features from an X-ray to make it easier to find other similar X-rays to help a radiologist, speed up diagnoses. And I think there's two insights from this. One, it was really hard. That's sort of one insight. But B, it was possible. We did make a dent, and we did have a novel mechanism of stacking autoencoders together to create these embedding models. So it sounds to me like a similar sort of featureization process that the team has discovered, both research and proprietary on your side for what actually correlates with clinical, significance. Mental health being one, diabetes obviously another case, and more physiology now, like more physical pieces. The other is that when I did not have a PhD. I was not pursuing a PhD, just an undergrad writing a paper. I realized that even if I make a dent here, it's going to take a long time to actually prioritize this and get this in the hands of radiologists. And I decided to go industry, quite early. So I had a similar experience of having made some dent, very, very small in my case, but realizing that the impact actually lies elsewhere. And that's why I joined Tesla. What I did is I was really fascinated with accelerating the transition towards sustainable energy and got an opportunity to do kind of machine learning at scale. But those are two kind of things that it reminds me a lot of the research I was doing in a very, very small capacity from an image first standpoint. The audio is novel, for sure.
Yeah, definitely. I think in the beginning, when you kind of leave academia, you have in mind this one application which is very similar, let's say, to something you've developed, or it's close enough so you can visualize it, like conceptually as well. But the more you actually are out in the industry, and I'm sure you saw that obviously like when you were at Tesla, and then beyond that, and like this is why you're doing what you're doing at Having AI, which is kind of like a next level thing, you see that the applications that you can actually develop with this kind of technology are so widespread, and the impact you can have is so much more than that, kind of smaller making a dent, which is kind of similar to what I experienced. Like I would only ever make a small dent in academia. But then similarly, like for us, like we started with mental health because that was my background, and there was like a very strong personal reason to do that. But we started offering this in the healthcare space, and yes, we grew to physical health as well, but we also realized, well, actually, this can make a big impact not just in healthcare, which is the obvious first application, but actually also in every other area where measuring something like fatigue or stress levels has an impact practically. And for us, that was actually safety critical environments. So one of our biggest applications is voice for health and safety. So we actually work, for instance, with automotive manufacturers who embed our models in their vehicles to detect driver fatigue through voice in real time to help avoid accidents. And that is a massive real world impact that I could never have imagined when I was doing the PhD. And you don't see until you're actually practically doing these things. And beyond that now, like with you guys, like at Having AI as well, you're seeing like with voice being or becoming the main way that people are interacting with computers, being able to make sure that that happens in a safe way is a massive deal. Like you guys are doing it like overcoming all the technical hurdles to make sure
we're end-to-end.
Yeah,
that's right. End-to-end infrastructure, naturalness. Those are the features that I think we're trying to measure and to make sure that it feels that the voice agents can pass a Turing test. That's the sort of ideal mechanism, or empathetic, and are able to, not hallucinate, not make up stuff, not give medical advice when somebody shows up right for an appointment booking and being like, hey, my tummy hurts, can I take a Tylenol? It's like, wait, just call 911.
Yeah, exactly.
We can't help you with that right now.
Exactly. And I guess for us then, like our part is like with those live human to computer interactions through voice, we are filling in the other part of the gap, which is kind of the safety nuances through voice. Like, is this actually a safe interaction? Like, is the human actually potentially in distress? Are they in pain? Are they, experiencing depression? Are they potentially suicidal? Is this a complex interaction that somebody needs to be supervising or needs to escalate and so on? So starting with healthcare was the original, then growing to safety critical across automotive, say defense, aerospace, and so on. But now it's like, well, actually, this can impact every single voice communication by adding a health and safety infrastructure layer that runs in the background and listens to what's going on so that you can actually intervene when you need. be that in a car or LLM or, in any of those different environments. So applicability is really, really scaled massively.
I think as also interesting to think, like you both have been mentioning basically this feel of starting in academic world with some very specific niche objective, and then seeing the ability to have impact growing and growing and growing. I think in this case, with voice technology in particular, this is now pushing us like to further accelerate and consider like broader applicability because of the pace of innovation that we're seeing. Essentially, like many of the things we started 6 years ago, and 6 years ago it was impossible to have a meaningful conversation with a voice agent. It was just like,
they didn't really exist.
It was a very difficult exercise, and not a pleasant one. And now it's becoming the norm, essentially. Any sure thing is going to be the prevalent way of communicating with LLMs. So with this going bigger and bigger, for us is also like pushing us where else this can add value. And there's one thing that, again, in the space of the things we should be working on and we didn't work enough on, that I believe will have big impact as well. And it's kind of appending on what you guys are doing in measuring, again, is the agent behaving properly? There's an interesting aspect, which is the agent behaving properly from the paralinguistic point of view as well, as in many of the modern text-to-speech part of the model are trying now to embed affect and emotions in the way they speak so that they can react more appropriately. But can we measure back that the reaction was indeed appropriate? Is the agent having a laugh in a difficult conversation? Maybe you don't see it from the text, but maybe the tone was not the right one. So I think there is space to expand also in that direction. It's like somewhat like the weird exercise of what if we measure the biomarkers not on the human only, but on the agent side as well.
That's pretty cool.
What can we learn?
Yeah, and what can we use it to train the agent better as well in reacting appropriately?
And I don't have the answer, but we're going to do it and see what happens.
That sounds good. Question for the team. What's the bottleneck, and this could be technical or this could simply be regulatory, to have this embedded everywhere, let's say? Like what are the blockers here? Is it mostly a data set curation kind of issue, and it's actually a technical primarily bottleneck for progress to just scale it up, right? And just follow some scaling law if there exists one kind of for your domain? Or is it more on the regulatory side where actually you have to work really closely with the NHS or whoever in the UK or like in the world you are working with to make this, required, complementary, subsidized? Like there's something here that feels, could be the barrier. So I'm curious, like what are the barriers for like mass? If we were to 100x the company or 10,000x, let's say, like massive scale, what would be the underlying pieces that would show up for the team?
Do you want to take some of it? I have some ideas, but I'm sure you have some different ideas. So.
I can take some of it. I think with these kinds of applications, I think context is everything. So the hurdle depends on the context. So if we're talking about a context or an application where you're affecting somebody's healthcare journey in any way, a pathway, then regulation becomes a big thing. So you need to make sure that you're doing this safely, you're a medical device, you're affecting the pathway in the right way, and so on. That's like its own thing. If you're looking at safety critical, on the other hand, which is not affecting a healthcare pathway, it's just affecting, do I intervene appropriately for safety, then that becomes a different story, and regulation sure is helpful. It's not the biggest blocker, I would say. But in terms of, say, ignoring, let's say, regulation and trying to 10x a company from a practical standpoint, then that's a lot more on the kind of data set and technical point of view. And I can kind of maybe hand over to you on that part. Yeah.
I think there's at least two different things that need to scale, essentially. It's one is what are the demographics regions where this is working correctly, essentially. Say, how many languages do you cover, to keep it simple? And the other is, can this run in all possible audio settings, essentially? And so maybe starting from the second one, it's quite interesting to see how we have been changing and adapting to what the new technologies are, and so what we can do and what we should be doing. If I look at our kind of model of serving this a year ago, or a year and a half ago, it was very much static interactions. So RESTful APIs, quite simple. The contract is you give me a snippet of audio, you poll for results, here's your scores, off you go. And so there was a lot of working with a customer to figure out what's the experience around it so that it did make sense and you get quality output. Now, that format, of course, will not work the moment you want to apply this in live conversations. Human to human, like this one, agent to human. It just wouldn't work.
Agent to agent.
Or agent to agent, why not? Like, I mean, it may be a thing, indeed. If it does work, it may be useful for improving them, for training them. But sure thing, if you want to do some live interaction, this doesn't quite work. So we've been developing a different way to serve models. And from the technical point, the new model that will make available soon enough, and if it's not end of this year, will be beginning of next year, is essentially creating a set of simple plugins for all major agent infrastructure, essentially, that would stream in the back end audio, text, agent state, anything that might be relevant, and then decides what to do with it, maintaining lots of logic, deciding, oh, this audio is appropriate for this biomarker provider, or this instead is more appropriate here, and collect this information, reporting back actions at the agent state. And these actions are now reasoned through a reasoner model. So that is never naked information like, oh, your stress is 0.356, like, which is not necessarily actionable. It might be in some contexts, but in most of the contexts it's not. So now we are appending the context, defining a policy. What do I do with these numbers in this context? What am I supposed to do with it? And some of the response may be for an agent to steer the conversation live. Some of the response may be to be logged for compliance purposes, for after the call review or anything else. So that's kind of the direction we are going, which is a big shift in how we are delivering the technology. And of course, a big challenge, how do you make it scalable and so on. And
Inference seems really hard. Yeah, inference seems really hard here because if you're doing low latency, guardrail style flows, the false positive, false negative rate has to be
exactly
good enough where it feels good, because offline you'll get the best results. Everyone knows that, but online that's really, really hard. It's quite a big jump.
Yeah, that's a big jump. Of course, there's a lot more impact to have in that space. And I think the other technical thing that needs to happen is just a transition from everything is in the cloud, slowly moving towards the edge. And we see that as kind of customer demand, essentially. Since these are very sensitive things we're pulling out, irrespective of the regulatory landscape, what people, users, are actually asking for is guaranteed privacy, essentially. Mm-hmm. And there's no better guarantee than showing that
on device or some embedded at the edge, closest to the edge of reality as possible. So that's hard. That's doubly hard.
That's another big direction for the future. We started exploring a bit. There is a path, but it's going to be a significant amount of work for the months to come, essentially, in moving in that direction. And I think I started somewhere else, and I said, I'll start with this part of the question, but I don't remember anymore, which was the... So we can stop here, or if you recall, we can jump back.
One question for the team. So audio-based features, they seem surprisingly useful, let's say, like based on the research and the actual practical deployments here. Have you thought about adding, let's think about the automotive use case or driver fatigue. Is it just voice, or actually do cameras, like are cameras more reliable? As in, what's the right... I have two questions there. One is, are you primarily looking for use cases where audio is underexplored, undervalued, but is actually superior from like a signal processing standpoint? Is that the theme, or is the theme to do some sort of fusion of other modalities and kind of getting more video data or like images to come through to analyze, for example, mental health, maybe not diabetes, I guess maybe not as maybe relevant, or maybe there is relevance there, but also the fatigue element of it. So we'll love to understand this like unilateral, hey, here's the feature set, or audio maybe is sort of one channel to go after. Are you thinking of going deeper there or adding more signals to the mix?
I think maybe it's helpful for historical, I guess, context. We didn't start with being unimodally speech driven. Like, we actually started with this multimodal approach, which was basically voice and video data and behavioral data, combining all three together to actually get a stronger, clearer predictive signal for something that is so difficult to pinpoint, like mental health. So actually, in our data set, we do have tons of video and behavioral data, and also EEG data coming in, blood biomarker data for diabetes and so on. So very, very firmly in the camp of the more data you have from multiple modalities, the more likely you are to get the stronger signal, because there's overlap, you kind of fill in the gaps. It is extremely valuable. There is a difference between what is valuable in terms of slightly improving signal, which could be like what we found, I think like one of our first papers was, if you combine voice plus video plus behavior, every modality you add improves relatively the signal by about 10-15%, relatively speaking. There's a difference between that and, in the real world, applicability and what users want and are willing to go through. Switching audio on versus audio plus video is very different in actually people accepting it. So voice is super easy. It's very frictionless. Video, less so. In terms of the automotive in particular and fatigue, you're right that there is existing kind of evidence that you can use cameras, basically. Like a lot of the trucks now.
Tesla, like Elon and team, the autopilot team. At least mine's complaining when I'm looking here and there. Yeah. I start getting beeps on my car.
Yeah. It's the thing. Yeah, you can definitely see kind of where the eyes are looking. However, the problem with the camera-based only detection is the latency of the predictions and the accuracy of those predictions across different ethnicities and types of faces and eyes and features and so on. So one is, if you are looking at camera-based feed for fatigue, typically it's based on how open are your eyes. So like, are your eyelids actually closed? In which case, it will flag up as it's a problem. At that point, you're probably asleep. So it's slightly too late. And then also they're looking at head drop as well. And again, if like your eyes are closed and your head's like this, you are asleep. You have very, very small latency with which the car needs to be able to react if this is a safety intervention. Whereas if you're doing our kind of approach, we are detecting fatigue as it is building up over time. So you're able to actually intervene sooner. And also on the eye part, one of the big issues with video-based models is that they're basically predominantly trained on Caucasian features. So if you're looking at, say, for instance, Southeast Asian drivers, a big problem and complaint we've heard is that it just does not work with their features. And so it will constantly be flagging them that they're asleep when they're actually awake, because the actual eyelids are so different that, the models have just not been trained on.
It doesn't generalize. Yeah, it doesn't generalize
Exactly.
to the.
It doesn't generalize.
To sort
We
of
don't,
get it.
exactly. We don't have that problem. And so we are seeing automotive manufacturers moving from video-based systems to actually just audio, and they're removing the cameras altogether from what we've seen. So I would say there is definitely value in having other modalities. Practically speaking, a voice is quite powerful on its own, and it's extremely acceptable. Yeah. I don't know if
That's super cool.
I think it's a good answer. Yeah.
That sounds good. I found actually a lot of false positives in the Tesla setting. I don't know what is going on, but yeah, I just put my shades on and try to just avoid the signal.
Switch it off. Yeah, a lot of people just switch it off.
That's cool. I'd love to understand kind of maybe like next 12 months, more tactically, what is sort of goals and objectives internally for the team? Kind of what are you the most excited about? It could be around voice in general. It could be some deployments in maybe like a healthcare setting or automotive setting. What really gets the team excited? What are you guys most looking forward to?
I guess we
You want
can
to go?
split. We can split.
No,
yeah,
no, no.
yeah. I guess it kind of. It's as Stefano was saying earlier, we were just kind of touching on with you as well. Like, I'm sure you're seeing this. Like, it's voices having a moment right now. Like, the world is very much rapidly moving towards voice first, human machine communication. 2025 was the year of the voice. It's fantastic for companies like ours. Like ours being both Thymia and Hamming. I think for us, one of the biggest things now is we've gone ahead and built like the world's first foundational voice biomarker model that has all these applications across health and safety. We're now seeing that in the next 12 to 18 months being actively deployed across multiple areas. Healthcare is one, but then also safety critical and actually large LLM providers and telecoms, like areas you wouldn't necessarily think we're actually being integrated as this health and safety infrastructure layer that has like a safety policy reasoner that is powered and enriched by the biomarkers we're creating. So that I would say deployment, super exciting. Regulation is very big. We're making sure that we're doing this properly. We're now, again, becoming the first speech biomarker company in the world to be regulated as a medical device. And you do that in different regions. We're doing that for mental health. And then diabetes is going to be the next one we're looking at. Diabetes itself is probably a very exciting next thing, like new conditions. We found very strong signal for mental health, but also respiratory health, like COPD, asthma, allergies, cardiovascular, hypertension, and diabetes. We're now pushing on diabetes as like the major thing that should be coming out. Now it's in prototype. It will be deployed in 2026. And then I don't know, like you were talking about edge deployment as well.
I mean, all these things are super exciting indeed. In terms of application, I think the one thing that excites me the most is where the surprising stuff. So where we find these technologies just being embedded in communications that were not necessarily meant to have this from the start, but they should, like general LLM communications, where it's actually extremely beneficial to take a look at mental and physical states of the user so that it's not deteriorating. And if it is, you can do something in time. You have access to that information essentially. So that's from the application point of view. From the research, indeed, on top of everything you said, that is great. I think the big innovation things that hopefully we'll manage to solve or at least to progress is, if on one side we've been learning how to hear speech and not wash away the information about mental and physical state. On the other side, what we can't do today, but would be extremely powerful to do, is be able to produce speech that doesn't wash out the same health-related information. And if you had that, you basically will have a super powerful engine to augment data sets where it's very difficult to find. Say you want to move in a new language, it's going to be very, very hard collecting large samples with the data labels you're after. But maybe you can produce speech in that language that carries that signal and complete the loop, and so on and so forth. So that's one big direction where we'll have some hints of things that work and things that don't work. That is extremely exciting. I think, if I look at the roadmap on the research side of the story, is all super exciting. On the engineering side of the story, indeed, like getting to a more scalable solution, closer to the edge, all of that is extremely exciting.
That's awesome. The data generation sounds quite useful to generate and augment. Yeah, that sounds really challenging to create high fidelity data synthetically that improves performance and is not simply kind of the tail eating itself, right? It's just sort of loss of signal fundamentally and just adding the same pieces through it. This sounds really fun. That's a pretty good year. Next 12 months sound really good.
Yeah. Here's hoping. Yeah.
Yeah.
Awesome. Look, this was great chatting. I learned a lot, and glad we went a little bit deeper around where the team came from, what the initial unique insights were and personal experiences leading to the creation of the company. And yeah, I think deployments and more technical breakthroughs, data and inference, that seems like the right kind of trifecta. That sounds all like quite excited. This is a pretty random question. Are you planning on providing APIs, generally for developers to be able to build on top of theirs? There's lots of folks who are building health applications, people who come to me and are asking. Sometimes people have asked me, hey, like, is there an API that we can plug in that can give these biomarkers and create a similar like Whoop-like coach experiences that are injecting maybe like multimodal data on their side, but adding your synthesis on top. Curious if the developer market is something that is a priority or not yet.
Yeah, I mean, we do have APIs for the more static interaction, what I described at the beginning, and we will provide APIs for this new
streaming,
live stream,
the online version.
Exactly. So APIs is basically the way we are actually providing the service. We have been building application on top of those APIs, mostly for demonstration. But typically, when we get to like an actual deal, in the end, the main driver is just the customer is building an application around it. So sure thing, the things are provided in that way.
That sounds great. Awesome. Great. I think we'll end on this note. And yeah, thanks team for sharing your experiences. And yeah, we'd love to do this again and go deeper around maybe product launches or things that are coming down the pipe.
Absolutely. Yeah. Thank you so much. It's a very, very interesting conversation. Thank you for the great questions and for having us. And hopefully having two people was actually still interesting, entertaining, and not too boring, like multiple answers on the same questions.
It was good. It was good. Both sides of the brain.
Yeah.
All right.
Cool. Thank you so much.
Amazing. Thank you.
Thank you.